Okay, so on our formula sheet, let's get this here. There are just a few things that we need to write down. From the first section, you had the area of a circle and the area of a circumference of a circle. So area is going to equal pi times the radius squared. So make sure you have that one written down. And then for circumference, there are two different things you can use. The one we're going to use most often is 2 pi times the radius. But there is another one that you can use for this. It is pi times the diameter. Okay, both of those came from that first little set of notes that we took that just basically had vocabulary on it. Okay. Everybody have both of those down. Okay, and then the only other one we got to yesterday was central angles. What I'm going to do is I'm going to write this in symbols, but I'm also going to just do an example on my picture here, because I think sometimes students do better with just like an example of it in front of them. So, central angles, we just learned that the central angle equals the measure of the arc. So since at A, we really just have one angle right here, I can call that angle A if I want, or I can call it angle CAB. And I'm going to put an M in front of it. So measure of angle CAB has to equal the measure of arc CB. Okay, so if we want to do an example for this, that means if this angle right here was, let's say 55 degrees, what would the measure of arc CB be here? Also 55 degrees. And it might be a good idea to put ourselves a little note right here that says the central angles of a circle add up to, and what do the central angles of a circle add up to? 360 degrees. Because if we wanted to, we could find arc, or the major arc here. I don't have enough letters to name it because I didn't put a point over here. But we could find this major arc here by just doing 360 minus 55, and that would give us our amount. I won't throw that in there because I don't want to overcrowd that example right there. Okay, everybody, make sure you've got that information down on your formula sheets. And then let's get out our notes from Friday. So your notes from Friday were the 6.2 notes. And I believe we had stopped right here. We did not get to inscribed angle. Okay. So, the problems that we worked on Friday are really like the key problems that you have to have. We're going to today look at several different scenarios. It starts to get a little bit like those centers of triangles where you have so many things going on. It's a little hard to tell which one is which. Central angles are primary. You're going to have more questions about those. We do need to be able to do these, but not all of your questions will be like this. And some of them will be very simple and straightforward, like a one-step question. There will be others that will be a little bit tougher. So we are now looking at inscribed angles. An inscribed angle, we already did this on 6-1. It's an angle with its blank on the circle with two sides that are inside the circle. What do you think goes in that blank? An angle with its blank on the circle. Specifically, it's talking about that point B right there. What could I call that point B? What? Vertex. It is your vertex. Okay? So, where a central angle went to the center, this angle right here has its vertex, that middle point, on the edge of the circle. Its endpoints are also on the circle. There, because your two sides are inside of the circle. Okay? Whenever you have an inscribed angle, you also have an intercepted arc. The intercepted arc is the arc that lies between the endpoints of the inscribed angle. So it is shown here on my screen up here. It's red. On yours, of course, I don't have the power to print color, so it's just black on yours. But it's talking about from A to C here. So if you want to mark that there, we could label it here. This would be my inscribed angle. And then this right here is my intercepted arc. Okay, and the key that you must know here is the degree of the inscribed angle is half the measure of its intercepted arc. So central angles are equal. Inscribed angles are half. Okay? So let's look at some examples. Okay? Some of the questions that you get will be very straightforward, like number 5. Okay? So number 5 gives you an angle right here. It is an inscribed angle because its vertex right there is an X on the edge of the circle. And then it asks us for arc ZY, which is the intercepted arc. What would we do to find this arc? It's not 57. What do we have to do to it, Lily? Multiply by 2. The angle should be smaller than the arc for inscribed angles. So we would do 57 times 2. That is going to give us 114, I believe. So this arc right here would be 114 degrees. Okay, so the arc is always bigger than the angle that goes with it for inscribed angles. So you will double it. All right, 6 is really just as easy, but it looks a little more complicated just because they've drawn some extra lines in here. So if we look at the angle that they gave us, it is an inscribed angle because its vertex is right here at F. And the intercepted arc that goes with it would be from one end point of that arc over here to the other end point. They ask us for the measure of QS. That is the arc that's intercepted. So this is the same as the problem they gave us before. They just have these extra lines drawn in here that make it look a little bit more confusing. So if this angle right here is 79, Jeremy, what do we need to do to find arc QS? Same thing as the last one. We just double it. So we're doing 79 times 2. And that will give us 158. So we'll get 158 degrees for that arc. Okay? Questions? All right, let's move over to our next one. All right, for 7, they give us this angle right here. And they give us 45, but they're not asking us for arc KL. They're asking us for arc KJ. Is this the intercepted arc? It is not. The intercepted arc is KL. It's this one over here. How would we find arc KL? 45 times 2, which is going to give us 90. So KL is 90 degrees, but they didn't ask us for KL. They asked us for KJ. What could we do? Okay, how do you know it's the same thing?
Because that's a little cut in half. So it's 180 plus 90 plus 90 equals 180.
Yes. Yes, because right here, this line right here is a diameter. It cuts the circle in half, right? That means this whole thing is 180. And to get 180, you could do 90 plus 90, or you could subtract 90 from 180 there. And arc, measure of arc JK is going to be 90 degrees. All right, try the next one on your own. Okay, so it is a good idea to highlight your angles on this. If you've got a highlighter, if you don't, I've got some up here you can borrow. If you highlight that angle, the arc that goes with it is from end point to end point of that angle. So this angle right here is 104. You're doing 52 times 2. But that is not the angle that they're asking you for. The angle that they're asking you for is arc FM, which is over here. But like on the last problem, it's a little harder to see because they got so many lines going everywhere. But right here, this is half of the circle, right? That's the diameter. It cuts it in half. So if this is 104, this one has to add up to be 180. So if we do 180 minus 104, we will get 76, and that is the correct answer there. So one of the big things you want to be looking for is diameters where you have half a circle. That is sometimes very helpful. a lot of times it's really helpful to sort of block out the other lines for pieces. So if you, like by highlighting that, sometimes you can sort of help just picture the pieces that you need. All right, we okay here? All right, let's go to example 8. This one is by far the toughest one we're going to see on these. What do you guys think? All right, Joseph. So that would mean 4x plus 3 equals the whole circle. So this is an inscribed angle right here, and this is the arc that goes with it. So is that the whole circle? No. Is it half the circle? No. Now, we are going to have to use the whole circle. We are going to have to do that. So we have to use 360 here. What would I do to this angle to give me this arc out here? I would double it, right? Now, I don't have a number that I can double easily, but I could do 2 times 4x plus 3, right? And if I did that, I would distribute, and right here I would get 8x plus 6. So this angle that I have marked is 8x plus 6. This arc right here is 10x minus 11. And this arc right here is 10x plus 1. So any ideas? We're not going to multiply by 2 because we don't have an inscribed angle anymore. The only inscribed angle we had was this one, and we've already multiplied it by 2 to get this. So now, what should we do, Kaylee? Yes. So if I take these 3 arcs right here, that makes up the whole circle if I put them all together, right? So I can add them together, 10x minus 11 plus 10x plus 1 plus 8x plus 6. And if I add all of those arcs together, that should equal 360 degrees because it's a whole circle. And so to solve that, it makes kind of a long equation, but after this first step, it goes back to being a pretty simple one. You got 10x, 10x, and 8x. So if you add those together, you'll get 28x. And then you have negative 11, positive 1, positive 6. That is going to give us negative 4 when we add those together. So I was just combining my like terms over here on this left side. Victor, once I get to this point, what would I do to solve that equation? I'll add that 4. So 28x is 364. And then divide by that 28. And somebody do that in the calculator for me. 13. So x equals 13. Okay, questions? Okay. Let's see. Before we go to the next little piece, let's give you guys a few minutes to the next part. Okay. Let me zoom in here. Okay, so these first couple were a little tricky because they're different than the examples from the beginning, this gives you the arc, okay? The arc is bigger than the inscribed angle. So the arc is bigger. You do not multiply this by 2. What do you need to do instead? Divide by 2. You're going the opposite direction. So you're going to do 66 divided by 2, and you'll get 33 degrees for that angle. How about number 8? What do we need to do on number 8? Same thing. They gave you the arc, not the angle. So you have to divide. 60 divided by 2 is going to be 30 degrees. Okay. Any questions on those? All right. Let's go down. We're going to look at 9 and 10, and then I'm not going to do the last couple just yet because not everybody's gotten there. So for this one, if you have a highlighter, it's a really good idea. And if you don't, you can come up here and get one. To highlight the edges of that angle right there. So if you highlight the edges of that angle, the arc that goes with it is the arc in between. So, is this arc the arc that goes with that inscribed angle? Yes. What do we need to do? Multiply it by 2. So we're going to do 52 times 2, and we will get 104 degrees for that one. Okay, and then over here we've got this angle right here. The arc that goes with it is the arc that goes from end point to end point, right? And we've got FGH is what they're asking us for. FGH, that is that arc, right? What do we need to do to get that arc? Multiply it by 2. So we'll do 83 times 2, and that will give us 166. Is that right? I do take. Let's look at 11. Whether you got to it or not, I think 11's good to look at because 11 starts to get a little tougher here. And this is where, like, highlighting can really come in handy. If I'm looking at this arc right here is 84. If I highlight from end point to the other end point, right, to see where that angle crosses, that would give me this angle. Is that what they want? Is that what they're asking for? It is not, okay? They are asking for this angle, which if we follow those lines on out, we go from L to D, we are looking for this arc. How could we find that arc? What? Okay? Whenever you're seeing something like this, you're looking for, like, either maybe you know something about the whole circle or you know half of the circle. And right here, this right here is the diameter. This is half of the circle, right? That's 180 degrees. So if we do 180 minus 84, we will get 96. So what I have marked in red right there, that is 96 degrees for the arc. They don't want the arc, they want the inscribed angle. So what should I do? divided by 2. So 96 divided by 2. And that is 48 degrees, and that is your answer that you're looking for. Okay, those are a little more complicated. Okay, let's fill in our formula sheet. So let's fill in our formula sheet for our inscribed angles. Oops, wrong thing. Formula sheet, inscribed angles. So get that formula sheet that I gave you here. Okay, so we're going to write it in symbols, then we're also going to just write it out, like write out an example, right? So, the arc BD, so measure of arc BD is going to be twice the measure of angle BCD. So the arc is twice the inscribed angle. I think a lot of times it's just more helpful to have some number examples here to see what is happening. So if arc BD was 80 degrees right here, what would the measure of angle BCD be? It would be 40 degrees. And I would add myself a note right here, the measure of the inscribed angle is less than the measure of the arc. Okay, these problems can range from very easy to very difficult depending on what information they give you. If you see one where they just give you this angle is 40 and ask you for arc BD, you should just double it and get the answer really quickly. Like we saw on some of the other ones where you got to set up equations or figure out different parts first, it can be a little bit trickier. But the thing to remember is that I will put both an easier problem and a more difficult problem on there. So even if you're having trouble with the hard ones, don't give up on it all. Some of them are just pretty basic. Okay, questions? All right, let's go on to the next piece, interior intersections. Okay, so if two secants or chords intersect inside a circle, then the measure of the angle formed is equal to half the sum of the measures of the intersected arcs. This is the average of the two intersected arcs. So, when these happen, they typically don't go through the center, because if they go through the center, you can usually just use central angles for them, which is much easier than trying to do this. But we have two lines that are crossing inside of the triangle, inside of the circle somewhere. And what this is telling you, this formula is telling you, is that this angle right here should be the average of the two intercepted arcs. And so the two intercepted arcs would be these two right here. Okay, so to find an average, you've been doing averages since you learned how to multiply and divide, right? So to find an average, you just add together, divide by 2, or add together, take half of it, in this case, because you only have two numbers. So if we want the average of 88 and 66, we just do 88 plus 66 divided by 2. And if we, we'll go ahead and grab the calculator for that one. So if we do 88 plus 66, be careful and hit enter before you divide by 2 or you'll get it wrong. So we get 77. Watch what happens if I do this, 88 plus 66 divided by 2. I get the wrong answer for that. So you either need to hit enter first or you got to do 88 plus 66 divided by 2, like that. But if you're using Desmos, make sure it looks like this. So we're getting 77. So 77 degrees. This angle right here is 77 degrees, and it didn't ask us for it, but this angle right here would also be 77 because those two angles are vertical angles. All right, now the second one is a little bit tougher because they give us 64 and 118. So if we find the average of those two numbers, we'll be finding this angle and this angle right here. They didn't ask us for that when they asked us for angle EGC over here. So this is going to take an extra step, but it's not all that difficult. So if we find the average of these two, right, to find an average of two numbers, you just add together, divide by 2. So 64 plus 118 divided by 2. Go over to our calculator. 64 plus 118 is 182. Divide that by 2. We get 91. So 91 degrees goes here, and 91 degrees goes here. But that's not the angle that it's asking us for. It's asking us for this angle over here, right here, that's the side of those angles. How could we find that? That's one way we can approach it. We could subtract them from 360, but if we do that, do we know this angle over here? We don't. But these two angles have to be equal to each other, right? So if we subtract those from 360, oh, hold on, I'm messing up here. 360 minus 91 minus 91. I get 178. That can't be right. That's an obtuse angle. But what could I do with that? I could divide that by 2 because that's the sum of those two angles, and you could divide it by 2 and you get 89. Or what I would do for this one, this angle right here that we just found and the one that we're looking for, what do they make when you put them next to each other? They make 180 degrees because that's a straight line, right? The arcs are not necessarily 180, but these two angles right here are 180. So, so you also could just do 180 minus 91. and that will give you 89 that way as well. And to double check it, if this is 89, this is 89, you could add them all together and make sure they still equal 360. Because if they don't, then you've done something wrong. Okay, questions? All right, so for this one, you've got, you're taking this arc plus this arc and dividing it by 2 to get the middle one. So 146 plus x divided by 2 is supposed to equal 112. And so to solve that, we could multiply by 2. 146 plus x equals 224. We can subtract 146 there, and I believe you're getting 78. Does that sound right? For your angle there, so, or arc, so this will be 78 degrees. Okay, questions? All right. Let's add this to our formula sheet. So skip over to that formula sheet there. We're looking at this picture right here. Oh, I should have labeled this point right here where these cross. Let's call that point right there A. So add that in, label that point, we're going to need it. So I'm going to write it out in symbols, but then we'll also just do an example for it as well. So the measure of arc DE, so this arc right here, plus the measure of arc BC divided by 2. So if I take these two arcs, add them together, divide them by 2, that's taking their average, right? It is going to equal the measure of angle CAB, or we could say DAE as well, because those two angles will be equal to each other. Now, if we do an example of this one, we could maybe say that DE is 20 degrees and BC is 100 degrees. So if we're wanting to find this angle right here, the measure of angle CAB would be 100 plus 20 divided by 2, which would give us 60 degrees. Okay, questions so far? Okay, just a couple more things we've got to do here on our notes. So a secant tangent intersection. If a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is equal to half the measure of its intercepted arc. It makes it pretty much like inscribed angles. Okay, so if we look at this picture and it asks me for the measure of CBD right here, then if I think of sort of like tracing this out, it's not exactly the same as the intercepted arc, but it's pretty close. I'm looking at this arc right here is the one that goes with that angle, and it's just going to be half. Just like with the others, the arc is, the angle is always smaller than the arc. So I would just do 128. Oops. That's a degree symbol right there. Divided by 2. And that is going to give me 64 degrees. So that would be this angle right here. $12 is pretty similar with just one little more twist. If this angle right here is 59 degrees, then the arc that goes with it, what should we do to find it? Multiply by 2. So if we do 59 times 2, I believe we'll get 118 right here. So that's this arc. But what did they ask us for? B over to F over to C. They did not ask us for the arc we just found. They asked us for the other arc. What would we have to do to find that? Subtract from 360. So we'd have to do 360 minus 118. And that will give me 242. I did not put this one on the formula sheet because I just want you to treat it like it is a inscribed angle. Okay, so I didn't put it on the formula sheet. It's just treat it like an inscribed angle. It's pretty much the same. You still have that vertex on the edge of the circle there. All right. Okay, this is our last one. Exterior intersections. If secants and or tangents intersect on the exterior of the circle, then the measure of the angle formed is equal to half the difference of the intercepted arcs. Okay, so this is what it's going to look like. It's similar to the ones that cross inside of the circle. But for those we added together and divided by 2, this is half the difference. So what you will do on this, if you are looking at like example 13, and they give you this arc right here is 77, and this arc right here is 28, and they're asking you for this angle out here on the outside. Instead of doing 77 plus 28 divided by 2, you will do 77 minus 28 divided by 2. So it's half of the difference. And so if we grab our calculator really quickly, 77 minus 28 divided by 2, we will get 24.5. Okay, 14 is the same type of question, but it's harder because you've got this arc here. There's your big arc. But do we know our small arc? That's what we're looking for, right? So we can't just do 114 minus a number divided by 2 equals something, we've got to like put an X right there. So for this one, we would have to do 114, I really didn't leave enough room right here, 114 minus X divided by 2 has to equal that angle on the outside. That'll be 34. So see how it's big arc minus small arc divided by 2 equals your angle on the outside. So in this case, you got to sort of set up an equation. Keely, what would I do to solve that equation? Very good. We got to multiply by 2 first. So we got 114 minus X equals 68. Okay, what next? We're trying to get that X by itself right there, so we need to get rid of the 114. And the 114 is positive, so we'll have to subtract 114. Which is weird because we get a negative number whenever we do that. What do we get? Negative 46. But this negative right here is still with our X. So if negative X equals negative 46, we divide both those by negative 1. Positive X equals positive 46. So we get 46 degrees. What do you guys think about number 15? No one gave us one number. Mm-mm. Mm-mm. What? Almost. What I hear back here? Okay, so they gave us what would be like the little arc. But in this case, since that's 2 tangent lines, the big arc that we need is the rest of the circle, right? So we could do 360 minus 109, and what does that give us? 2, what? 51. Okay, so this angle is 251. So now we've got the big arc and the small arc. So we can just use that formula like we did on the first one, and we can do 251 minus 109 divided by 2. And so 251 divided by 109 is going to give me 142. And I'm going to divide that by 2 and get 71. Does that look right? Might need to grab the calculator on that to make sure. Yep. So 71 would be this angle out here. All right. Questions on that? All right, let's add this to our formula sheet over here. And then you guys will work on the rest of this worksheet for your assignment. Okay, for this formula sheet, in symbols, to find the measure of angle BCD, that's this angle right here, that outside angle, we would do measure of arc BD minus measure of arc FH divided by 2. Alright, so big arc minus small arc divided by 2. And then if we want to do an example here with some numbers, let's try to pick pretty easy numbers. Let's do like 100 degrees out here and 40 degrees right here. So measure of angle BCD would be 100 minus 40 divided by 2. That'd give you 60 divided by 2, which would be 30 degrees. So that would be this angle right here. Alright, so we got about 5 minutes or so before we need to start packing up for you guys to finish working on that worksheet. We've done a lot of it together, but you've got some to finish. So go ahead and work on that for a few minutes. It will be your assignment if you do not finish it.